Okay, so the first step in solving an absolute value equation is to make sure you isolate the absolute value. I personally like to always keep my absolute value on the left side, so if I have an equation where it's on the right side, I flip it around and you'll see why later. But make sure it's isolated. If there's anything added, subtracted, multiplied, or divided on the outside of your absolute value, just use your opposite operations and move it to the other side. So the next step, always check and make sure your absolute value is not equal to a negative number. We know that that's not possible. So in that case, if that happens, you need to go ahead and just stop right there. The answer is no solution. Step 3, we're going to break our absolute value equation into 2 equations. So the first one we're going to keep exactly like it is, but drop the absolute value bars out. The second equation, we are going to drop the absolute value bars out, but negate whatever it's equal to. So since this is equal to 3, this one will equal negative 3. And then we just solve each equation. So we're going to add 2 to each side, and we get that x is equal to 5. And then also add 2 to each side, and we get that x is equal to negative 1. In this case, we will have 2 solutions, negative 1 and positive 5. In most of these, you will end up with 2 solutions because we know that absolute value is the distance on the number line, and there's 2 directions that we can go. If we say, what number is 3 units from 0 on the number line? Well, it could be positive 3 or negative 3. So just kind of keep that in mind. Let's look at the second one. So to start out with, we want to isolate the absolute value. So we're going to start by adding 4 to each side. You get that? You just treat that absolute value part like it's a big X that you're trying to solve for, and get it by itself. So then we have the absolute value of x plus 1 is equal to 2. Again, make sure it's not equal to a negative number, which it's not. So then we break it into our 2 equations. We have x plus 1 equals 2, and then we have x plus 1 equals negative 2. Remember, the first one you keep the same, second one change the sign, and then solve. So on both of these, we're going to subtract 1 from each side of the equation. And for the first one, we're going to get x is equal to 1. And for the second one, we're going to get x is equal to negative 3. All right, so why don't you pause the video and try the third one. Okay, so solving this one, we would subtract 4 from each side first. Remember, when solving equations, we always get rid of addition and subtraction first. So that leaves us with 4 times the absolute value of x minus 3 is equal to 0. We would then divide each side by 4. Never distribute inside an absolute value. Always strip stuff away from it. So that gives us the absolute value of x minus 3 is equal to 0. At this point, we would just check it's not equal to a negative number, and then we would break our equation into 2 equations. But in this case, because it's equal to 0, we're only going to have 1 equation because you can't negate 0. So we have x minus 3 equals 0. We would add 3 to each side, which leaves us with x is equal to 3. So here's a situation where we only end up with 1 solution. Pause the video again and try number 4. When you're done, start it back. So remember, first step, get the absolute value by itself. So we subtract 3 first, then we divide by 2. Once we get here, this is why we have that step to check. We can see that we have the absolute value of, and it really doesn't matter what's inside there, of something is equal to negative 1. Well, we know that that is not possible. We cannot have the absolute value of anything equal to a negative number. So in this case, our answer is automatically no solution. This is why in our steps, we say to make sure that you check your answers because extraneous solutions can occur. Extraneous solutions, what that term means, it means that you solve the equation correctly, you have a solution, but when you check your solution, it doesn't work. It doesn't make the equation true. And normally it's because there was something wrong in the beginning, that like there was something wrong with the equation, or there is something that doesn't work. So I'm going to show you what I mean real quick. If we had not caught the fact that the absolute value could not equal negative 1, and we had solved this problem anyway, we would have gotten that x equals negative 3 and that x equals negative 1. Well, if I check this by substituting negative 3 back in for x, so all I've done is take the left side of this equation and I've substituted in, and I work using my order of operations, I come out with that it's 5, but it's supposed to end up equaling 1. So you can see that when we work it out and try to put it back into the original equation, it does not make the equation true, and that's why we call it an extraneous solution. But again, if you just check from the beginning, you don't have to stress about that. All right, so this next one, again, we start out by getting the absolute value by itself. So we're going to start out by dividing each side by -5. So once we do that, and the -5 on the left side reduces, we have the absolute value of x minus 2 is equal to 3 minus 8x over -5. Well, in this case, we can't check to see that if it's equal to a negative number because we don't know, because it's got this x on the right side too. So here's a situation where when you get done solving it, you must check both your solutions because they could work, or maybe only one works, or none of them work because we have x's on both sides of the equation. So go ahead and break it up into your two equations. We have x minus 2 equals the 3 minus 8x over -5, and then the same thing, but then we need to negate it. So since we have that -5 in the denominator, I'm just going to make it +5. Go ahead, work out both equations, pause the video, and make sure you check your solutions, and then start the video back up to see if you did it correctly. When I break it up into the two equations, the first one, I multiply each side by -5. Make sure you distribute over here on this left side. Make sure you don't just multiply the x by -5. Make sure you multiply the x and the -2. And then we get -5x plus 10 equals 3 minus 8x. You know, do your opposite operations. We get -7/3. You can see on the other side, multiply each side by 5. Do your steps. We get x equals 1. But we can't just be like, oh, yeah, we're done, and box in our answers. We need to check and make sure that both of them work. So you can do this by hand. You can use a calculator. You can use a graphing calculator. There's lots of different ways to substitute back in and check. For those of you who are using a graphing calculator, one of my favorite features on the graphing calculator is to store answers. So that's what I'm going to do real quick. I'm going to type in -7/3, which was our first answer. And then right above this home button, I'm going to click store. And then I'm going to put x. Press enter, and it'll store that value for x. And then I'm going to type in each side of the equation. So we have -5 times the absolute value. To get your absolute value, just press alpha window, and the absolute value will come up. And then just click x minus 2 and arrow out and press enter. And then type in the other side of the equation, which was 3 minus 8x. And press enter. And what we see is, that these are not equal. They do not come out to be the same value. So we know that -7/3 cannot be our answer. So then check 1 the same way. So again, to walk you through this, you're just going to click 1, store for x. Press enter, and then just type in each side of the equation. So we have a -5 times the absolute value of x minus 2, and then just arrow out, and it'll give you an answer, and then type in the other side, which is 3 minus 8x, and it also gives you -5. So because those come out to make both sides of the equations equal, we know that that answer or that solution works. All right, so just for your notes, and you can use Desmos and other ways to check it, but the -7/3 gave us that -21.6 repeating was equal to +21.6 repeating, which we know is not true. When we substituted 1 back in, it did work. So in this case, we only have one solution. Don't stress. You're not going to have to do this for every problem. The reason why we had to check is because we had that x on both sides. So we couldn't check to see if it was equal to a negative number to work it out. All right, try the last one and pause the video and then check it when you're done. Okay, so now we're going to get into absolute value inequalities. So just a real quick note, remember when you're graphing inequalities on a number line, if it is a less than or greater than, at that number you will leave an open hole. But if it's less than or equal to or greater than or equal to, you will use a closed hole to show that it is also including that number, that it is equal to that number. All right, so these inequalities are going to end up being compound inequalities because you will end up solving two problems and you'll have to put those inequalities together. So if you have an AND problem, it's going to be the intersection. When you graph them, you're going to be looking for the intersection of the two graphs, where they overlap. Where if it's an OR problem, it's the union. So pretty much just anything that you graph, you pull it down and include it in your solution. So here's just a couple of examples. Let's say you work out a problem and you have x is greater than 2 and x is less than 4. Above your number line, you're going to put your numbers on there. Really, you just need to put the 2 and 4. You're going to graph x is greater than 2 and also graph x is less than 4, but do it above the number line. And then you look to see where do they overlap. And we can see that they overlap between 2 and 4, but not including those numbers because there's an open hole at 2 and there's an open hole at 4, so they do not intersect there. So then our solution is all real numbers between 2 and 4, not including those numbers. Remember, when you use interval notation, when it's not equal to, we use a parentheses. If it's equal to, we use a bracket. So we have the solution from 2 to 4. The next one's also an AND problem, but in this case, they don't go in opposite directions, they go in the same direction. Remember, because it's an AND problem, we are only looking for the intersection of the two. So in this case, they only end up intersecting from 1 to infinity, not including 1. So that's why we have a parenthesis at 1, and then we put infinity. Anytime you use the symbol negative infinity or positive infinity, we always use a parenthesis, not a bracket, because infinity is not a specific number, it's more of an idea. All right, the next two are OR problems. So the first one, we have x is less than or equal to negative 1, or x is greater than or equal to 3. Because it's or, it can be either one. So once you graph above, you just pull it down to the number line. And since it covers all those values, we're going to write our solution from negative infinity to negative 1 with a bracket in union with from 3 to infinity, a bracket on that 3. So what that means is our solution could be any real number up to negative 1, and then any real number from 3 to infinity, but not the numbers between negative 1 and 3. All right, the last one is also, excuse me, I am so sorry, y'all. The last one right here is an OR problem. And these also go in the same direction, but because an OR problem is a union problem, instead of looking for where they overlap, the x is less than or equal to 5 is going to override the x is less than 1. Because if it's x is less than or equal to 5, that includes x is less than 1. So you pull all of it down, the union of the two, and that is why our solution is negative infinity to 5, including 5. Remember, always write the solution using interval notation. All right, step 1 to solving an absolute value inequality. Make sure you isolate the absolute value. Always make sure it's on the left side of the equation, and you'll understand why in just a second. So we're going to subtract 1 from each side. That'll end up giving us 4 times the absolute value of y minus 3 is less than 8, and then divide each side by 4. So we have the absolute value of y minus 3 is less than 2. At this point, you must determine if it is an AND or problem. This is why the absolute value needs to be on the left-hand side. If you have the absolute value is less than, it is an AND problem. So I know this might sound silly, but the way I've always thought about it, if it says less than, I think of it as less than. If it's greater, I think about it as being greater. So if it's absolute value less than, it's an AND problem. If it's absolute value greater than, I think greater, it's an OR problem. All right, at this point, we then break it up into 2 inequalities. The first one, just drop the absolute value bars out, but keep it exactly like it is. Again, we decided that this is an AND problem. Then the second one, drop the absolute value bars out, but you're going to now flip the symbol and change the sign. So unlike equations, which you can flip in equals all day long, it's still going to be equals. But unlike equations where you only negate the sign, with inequalities you have to switch the symbol and negate the number. Then solve. So we're going to add 3 to each side, so y is less than 5. And then we're going to add 3 to each side, so y is greater than 1. All right, so go down to your number line. Just put the numbers that you're dealing with. Do not worry about putting 15,000 numbers on your number line. You're just using the number line to be able to get to your solution. So graph each of your answers above the number line, not on it. So y is less than 5 would look like this. Y is greater than 1 would look like this. This is where the and versus or part is extremely important. Because this is an and problem, we are looking for the intersection of these graphs, where they overlap. So in this case, they overlap between 1 and 5, but not including those numbers. So our final solution for this problem is going to be from 1 to 5, but not including those values. And remember, we're going to use interval notation. You can also write your answer like this. 1 is less than y is less than 5. That's really what that means. But that's not how I want the answer. If you want to write it both ways for your understanding, that's fine. But we are going to be looking for your answer to be in interval notation. Okay, pause the video, try the next one, and when you're finished, start the video back. We divide each side by 2. We get x plus 2. The absolute value of x plus 2 is greater than or equal to 6. Greater is an or problem, so we break it up into our two problems. First one, keep the same. Second one, drops the absolute value, switch that inequality symbol, and change the sign. So when we solve, we subtract 2 from each side. We're going to get x is greater than or equal to 4. Or when we subtract 2 from each side, we're going to get x is less than or equal to negative 8. Again, make sure on your number line, put the numbers in the correct order, and just graph above the number line. So we have x is greater than or equal to 4, closed hole, shaded to the right. X is less than or equal to 8, closed hole, shaded to the left. Because this one is an or problem, we want the union in this case. We want to pull it all down. So pretty much you're just going to kind of take that and just pull it down, and it looks exactly the same. But when you state your answer, because it's two different inequalities with a break in the middle, make sure you use that union symbol. So our final answer is going to be from negative infinity to negative 8, bracket, in union with, bracket, 4 to infinity. Remember, those brackets represent that it is equal to that number. Parentheses means not equal to that number. Okay, try the next two, and then start the video back. So for number 9, we end up with, for the first one, 0 is greater than or equal to 0. Well, guys, anytime we solve an equation or an inequality and we reach a true statement, which is always true, the answer for that statement is all real numbers. So again, because this is true, 0 is greater than or equal to 0, for this part we're going to have all real numbers. The next one we have n is less than or equal to 0. So we graph both of these. Remember, all real numbers would be every number on the number line. And the next one is n is less than or equal to 0. So that would be a closed hole at 0, shaded to the left. Because this is an or problem, we want to make sure we graph the union of these two solutions. So that's kind of like you just pull them down. They like melt down onto the number line. When that happens, that all real numbers is going to override n is less than or equal to 0. And so we end up graphing the entire number line. So our final solution is all real numbers, and in interval notation, we will write that as negative infinity to positive infinity. It means the same thing as all real numbers. If you kind of think about it, it makes sense. The absolute value of any number is always greater than or equal to that number. Of course it is. If they're positive numbers, they'll be equal. If it's a negative number, when you take the absolute value of it, it becomes positive, so it's definitely going to be greater than its negative number. All right, so once we solve for the absolute value in this case, we end up with the absolute value of 2x is less than negative 4. Therefore, this is an and problem. We finish solving, and we graph both of them. Remember, when it is an and problem, you are looking for the overlap between the solutions. But in this case, they go in different directions and they never overlap. There's nowhere that these intersect. Therefore, you want to make sure you leave that number line blank. Do not pull these graphs down. Some students will think, if this looks like a or problem, then and make it or. It's not, it's and. So leave the number line blank. And the answer in this case is no solution. Now, I always have students ask me, well, of course it was, Ms. Salter, because right here it was equal to a negative number. Be careful. This is not an equal symbol. This is a less than symbol. So yes, if you think about it, it makes sense because the absolute value of any number cannot be less than a negative number because that would make it negative. However, had this symbol been greater than right here, it wouldn't have then been no solution. It actually would have been quite the opposite and been all real numbers. And we can talk about that in class. So just be careful about that. All right, read the problem, and then try to see if you can figure it out. Then when you're done, start the video back. All right, so whenever we are doing a word problem or modeling, the first step is always to define your variable. So in this case, P, I'm going to use P for percentage, is the actual percent of citizens who vote for the Democratic candidate. All right, but of course in this recent poll, it shows that 47% are going to vote for this candidate. Well, because there's a margin of error, because we know statistics is not perfect, and if you take AP statistics, you'll learn all about margin of error, they could be off as much as 4.5%. So what we're going to do is we're going to say the difference between the true proportion of citizens who vote for the Democratic candidate and what we think it's going to be, which is 0.47, my statistics brain there for a second, which is 47%, is going to be less than or equal to 4.5%. Now, the reason why it's less than or equal to is because a margin of error, that means within that. It could be as high as 4.5% over 47% or as low as 4.5% off of 47%. So we work it out. It's an and problem, and when we put it together, pretty much we can see that it could be anywhere from 42.5% all the way up to 51.5% of voters that vote for this candidate. So will we be able to determine if the Democratic candidate will win the election? No. If the vote comes anywhere between 42.5% up to 50%, they will not receive the majority of votes. We can't say whether he will or will not win, or she. All right, and that concludes today's lesson.